to complete the square to solve, now this is factorable. I already know that I can factor 7 and -3, but that's not what we're focusing on today. We're focusing on just refreshing our memory with completing the square. Why do I complete the square? Like, what's the purpose? Who remembers?
Oh, it's not factored.
Okay, if it's not factorable, one of the options for solving is to complete the square. It's really nice to practice completing the square with factorable equations because you'll get integers as answers. That's why we're going to do this one. We know it's factorable. It's okay. We're still going to practice completing the square. When we complete the square, what are we doing?
Trying to find it for years.
We're going to isolate so that we can get a new, that third term, right? You both were actually saying it at the exact same time. We're going to get rid of that C value and we're going to add in a new one. And why are we going to add in our own C value? What is it that like our new C value is going to do to our quadratic? It's going to make it a perfect square trinomial, exactly. Because from there, we're going to be able to solve. We're going to rewrite our trinomial so we can solve it. Okay, so where would I begin here? Yeah, I'm going to add the 21. I'm going to isolate so that I can get the C value gone. X squared plus 4x. Now I need to figure out what C value I'm going to add in to make the left side of my equation a perfect square trinomial. How do I do that?
4 divided by
B over 2 squared. So we have our B value is 4. 4 divided by 2 squared, which will be 2 squared, which is 4. So I'm going to add this where? To both sides. Why both sides? Yeah, we need our equation to stay balanced. I can do anything to one side of the equation as long as I do it to the other side. So now I have 25 on the right side. What do I have on the left? I'm going to rewrite it now as a binomial squared. What is my binomial? X plus 2. Good. What's the little shortcut? Where can I get that 2 value? Where can I find this? If I had like a fraction or something and I was like, I don't know what it is. Without going through all the calculations, where did that 2 pop up before? Right there. Right? That value is what's going to end up in your parentheses. Because think about what that is. That term times itself gives you the last term of your quadratic, but that term times 2 gives you the number inside that B term. From here, the reason I wanted to rewrite that, I can't get x by itself here and solve, but now I can. I can use inverse operations and get x alone. What would I do to get x alone here? Find the square root. So x plus 2 is going to equal what? 5, or x plus 2 will equal -5. And then I can finish by solving both equations. I can get x by itself here, so x is 3. I can get x by itself here, x equals -7. And then to take it, so that we did that before the break. Also, we rewrote our quadratics by completing the square into vertex form. And we'll go over that as well. We'll use the same quadratic. So our vertex form looks like this. Actually, I'm going to change that. Y equals x plus k or h. I forget. So this is the format, and this represented the x value of our vertex, and this represented the y value of our vertex. I hate that they end up using other variables, but we can actually get this into vertex form by completing the square. Where did we begin? This was Thursday. If you weren't here Thursday, I posted the lesson online, so definitely watch it. If you were here, this is a good refresher. How can I get this into vertex form? I'm going to complete the square to do it. What's the first thing I can do here? Add 21. Good. I'm going to add 21 to both sides. So we have y plus 21 equals x squared plus 4x. Now what?
The b divided by.
Now I'm going to complete the square. I'm going to do my b divided by 2 squared, which is 4 divided by 2 squared, so that's going to be 4. I'm going to add 4 here and also 4 here. So I have y plus 25 equals, at this point I can rewrite this as my perfect square, as my binomial square. And then the last thing I would do to get the vertex form would be what? Just subtract the 25. So vertex form, this equation is y equals x plus 2 to the second power minus 25, which means, what's the vertex of that equation? -2, -25. Good. So we spent time before the break working on that. The one quadratic that we used did not have a coefficient before the x squared. Today we're going to do these two same things, except we'll have a coefficient before the x squared. We'll go over how we're going to get this whole process done the same way. Almost everything is identical. There's like one small difference. We talked a little bit about it on Thursday, but we'll go through this example and figure it out. So here we have a flower garden, and it's 3 square plots, and then they're surrounded by like a border. We know that the total area is 100, so we're going to figure out what the value of x is. Okay. How would we find the area of that garden based on its shape? Length times width. Good. Okay. What's the length?
1
No.
plus
Be careful. What's this whole length?
1 plus 2.
Say again.
3
3x plus 2. X, x, and x. 1 here, 1 here. So we have 3x plus 2 is the length. I know that 1 looks a little tricky, but it's actually just showing you that this gap here is 1.
Oh.
How about the width? What's the width? Woo, not what I wanted to do at all. Okay, what's the width? X plus 2. Yeah, that borders on both sides, so x plus 2. And then what's the area based on the information we were given? 100. Good. So this equation is going to give us the area. If I distribute this out and FOIL it, I end up with 3x squared plus 6x plus 2x plus 4. If I wanted to start simplifying, what would I do? What are my like terms? Yep, I can combine my like terms, my 6x and my 2x, and I would get 8x. So I could rewrite this. How would we complete the square? So I went ahead and did the first thing I isolated that c value. I needed to get rid of it so I can add a new one. What's the important thing right now? We have 3x squared plus 8x equals 96. What's the difference between this problem and the ones that we have done before? Like all the other ones that we completed the square for. Okay, well not all the ones were because we were moving that c value. What's different about this one? In front of the x squared we have a coefficient. We have a coefficient of 3. Now when we complete the square we don't want that to be. Or we want it to be just 1. What can I do so that 3x squared is just a 1x squared?
Divide by
If I divide this by 3, what else do I have to divide by 3?
96.
What else do I have to divide by 3?
The 8.
I would have to divide everything here by 3. I can do that, right? Right now I'm going to be dealing with a fraction when I complete the square, but it doesn't matter. I'm still going to end up doing the same process. Okay? The key here is when we complete the square, we don't want there to be a coefficient with that x squared that's not 1. So we'll do whatever we can. We'll divide out. Pull back. I don't even know what's going on with that. It sounds like a tugboat, like leaving the port. Has anyone ever been on a cruise ship? Because that's what it sounds like when you leave the port. And like does like the, although the Disney one, they do a Disney themed horn. I'll call down to the office and just let them know it's making crazy sounds.
I thought that was somebody else.
See?
I thought it was.
Sounds like a dying cat. I don't know. Alright, anyway, so here we have this. If we divide both sides by 3, this is our equation now. Right? We can complete the square from here. Now, it doesn't matter that we're dealing with a fraction. What would we do to complete the square? We would do b over 2 squared. Right? So, but it just so happens now, what's our b? 8/3. Okay, so we're going to do our b value divided by 2, and then we're going to square it. How would I do 8/3 divided by 2? Yeah, 8/3 times 1/2, which would be 8/6, which we could reduce to 4/3. So really, this becomes 4/3 squared. What is 4/3 squared? Yeah, it would be 4 times 4 and then 3 times 3. So this would be 16/9, which means where am I going to add that? To both sides. Good. So what I'm going to do, 16/9 is going to be added here, and then here I'm going to add 32 plus 16/9. We'll get to that in just a moment. Now, if I needed to factor this trinomial, I already have a little shortcut. What is my binomial? What's the second number in it? Yeah, we already had that. It's here. It's inside this parentheses. So we have x plus 4/3. And then the other side of the equation, 16/9 is actually 1 7/9. So we have 33 7/9. Now I know we're dealing with fractions and decimals, and that's crazy, and on the next slide I'm going to show you what the decimal is, so you're not going to have to go through the whole process of finding it right now, but what would I do to solve right now? First I would find the square root, and then how would I get x alone? And then I would subtract the 4/3. Good. So it looks like this. Once I have our 16/9, I can find the square root here. My equation ends up being x plus 4/3, which I'll just say 1.3, it'll make it a little bit easier, equals 5.81, and x plus 1.3 equals a negative 5.81. So if I subtract 1.3 from here, and then I subtract 1.3 from here, I would end up with 4.51, and here I would end up with negative 7.11. Now nothing changed. The only thing I had to do at the beginning when I looked at this whole problem and saw that I needed to complete the square was what? What was the only difference? I needed that coefficient, whatever it was, I needed to divide it out. All right, and the key here, what most people forget to do is to divide it by everything. Most people are like, all right, I can divide this and then divide the other side. They forget that middle term, like to divide everything. Okay. So this one was estimated a little differently. So now I want you to try this one. Using the same process, try this one. How would you get the z by its how would you get the z squared coefficient to be a 1, and could you complete the square from there? If you don't get to the end, it's okay. You're going to get to a point where you're going to have a decimal. It's okay. We'll go through that part at the end together. No, you won't need it. Because when we get to the end, we'll do it together. You can get pretty far with this one without a calculator. If you had one that was extremely complex, I do believe it would be in the calculator section on the part, but you'll see even in the practice problems that a calculator wouldn't necessarily be needed for the majority of the ones you'll see in practice. Get as far as you can without a calculator here. You can. Yeah, just do like a number 0.5. For that part, you could leave that as a fraction. It's like 3 halves might be easier for you to do a calculation within 1.5. Especially if you're going to square it, because you're going to end up multiplying whatever you have by like a fraction might be easier in that situation. But like on the other side, I like keeping that as decimal, it's just me. If you're getting to a point where you're stuck and you feel like I can't do this calculation, you can pause at that point. We'll go through this just so you can see what it looks like to go through it entirely. Well, what I need to do before I can actually complete the square here. Yeah, I need to divide everything by 2, and most people miss the 3. They would divide this by 2 and this by 2 and forget that if you're going to divide those by 2, you have to divide here as well. Which gives us z squared plus 3 halves z equals what?
67.
Yeah, 67.5. And I know right now I have a fraction on one side and a decimal on the other. That's okay. I know that I'm going to be doing some more calculations with the 3 halves, and I think it's a little bit easier for myself to do those calculations with a fraction, so I'm going to leave it. Okay. To complete the square now, what am I going to do? Yeah, I'm going to use the same thing, and it doesn't matter, right? Today's big thing is it doesn't matter if that b value is a decimal or a fraction or an integer. You can still divide it by 2 and square it to find the c value. 3 halves divided by 2 is the same as 3 halves times 1 half, which is 3/4. So this becomes 3/4 squared, which is going to be 9/16. Right? So I'm going to add, so I'm going to do this. I'm going to add 9/16. And here, I'm going to say 67 and 8/16 plus 9/16. So I have 68 and 1/16. So 68.05. Pretty sure that's what it was. I can rewrite this. I already know what's in the parentheses. What's the second term in my parentheses? 3/4. Yep, and I can just say 0.75 at this point. 68.05. Now, if you were asked to keep going and even if you had to just estimate near square root, what should 68, the square root of 68 should be around what? Yeah, it's gonna be between 8 and 9. The square root of 64 is 8. The square root of 81 is 9. What do we think? 8.2? We'll run with 8.2. So z plus 0.75, after we find the square root, equals 8.2, or z plus 0.75 equals negative 8.2. So if I subtracted 0.75, z equals 7.55. And then here we would have minus 0.5. Z equals negative 8.95. Hi.
Hi, I just saw Miss Toll,
Okay.
and she said, I think you have some of these, or something like that, she said. Some, these
Oh,
are the kids
some of
that
them?
didn't-
Okay.
Do you have them?
Who?
I don't know, Miss Toll said she said Caravano has them.
Right now?
No, I'm saying you have them like, she said you didn't hand them in to me yet, did you?
Yeah, I did.
That's what I thought.
Yeah, she left them for me. Remember, and I gave them to you.
Okay.
And I
just wanted
emailed you and thought that maybe because she wasn't here that day that her kids didn't get them filled out, but all my kids did.
Okay, no, hers didn't. That's why
Oh.
I just went through those didn't do them yet.
Oh, that's
Can I
the
have-
class?
Yes, that's hers, and then she said she bought like this group.
Okay.
You still have them. You don't, right?
Yeah, that's my period 3-4. So I base kids. Yeah, that's all highlighted. They're all the same class.
Oh, yeah, no, the highlighted she's taking them.
Oh, yeah.
All right, okay.
That is that it?
No, the highlighted she's taking them.
Yeah, no, that's my first period.
I don't know why they're taking them.
I never got those forms. I was supposed to get 3 right now. I can give them tomorrow morning. No problem.
Yeah, I'm not, you know what, I'm gonna run them over
Yeah,
Tuesday.
okay.
So no big deal. Thank you.
Ms. Caravano,
Yes,
pardon the interruption. Can I have Arely Montes for dismissal?
yes.
Thank you.
Oh, yeah. Okay, so that's how we can complete the square root coefficient. A little bit more complex, but the only reason it becomes that is because some of the calculations you're doing with fractions or ultimately decimals. Now, if it's a overly complex calculation, I do believe that would be in the calculator section, but in the practice, you'll see some of them don't require a calculator because everything's divisible, right? Like if in this problem here, this was these were all even numbers and everything was divisible by 2, then you wouldn't need to have a calculator, you'd be able to do those calculations. You'll see what I mean when we practice. But let's now look at how we can take a coefficient before the x squared and put it into vertex form. Right. So on Thursday, before the break, I showed you an example of this so that you can see it. And we're going to just talk about it really quick. Same idea though, I don't want the x squared to have a coefficient greater than 1. I really want that to be a coefficient of 1 before I do anything. Right. How would we... I keep thinking it's you. Okay, how would we begin? We can actually complete the square to go from standard form to vertex form. Where would we start? So you could divide by 2. And the reason actually, you'll see a lot of the examples of this, they would isolate the 4 first. I think it's because there's a chance that may not be divisible by 2. You give yourself a much greater chance if you add the 4 here first. And even all the examples I see, they always have that C value go to the other side first. Now from here, here's the problem. Even if I left the 4, if I divided out by 2, I'd have to divide my y by 2, and I don't want that. So what's a way that I could get the 2 out from the x squared, but not have to divide it by on both sides? Because here's the problem. Let's do this for a second. Imagine I just left it here, and I was like, I'm just going to divide everything by 2. So I divide by 2, divide by 2, divide by 2, but then I have to do that. That's a problem, right? I don't want to divide my y value by 2 if I can avoid it. So instead, once I isolated that c value, what can I do to get the x squared, like a coefficient of 1? Without changing the value in any way. I don't want to change the value, but I need the x squared to have a coefficient of 1. What can I take out? Like, I want it to look like that. What can I do with the 2?
You can use parentheses, right?
Yeah, I can use parentheses. I can factor out a 2. What would be left inside? A 6. Yeah, 6x. So I can do that. I didn't change the value in any way, but now I can actually complete the square. Because here, what would I do to complete the square? Think about completing the square now. What do I do? At this point, if this is the square I need to complete.
Oh, the divide. 6 divided by
Yeah, b divided by 2 squared. So 6 divided by 2 squared, which is 3 squared, or 9. So I'm going to add 9 here. What am I adding to the other side? Say it again. Why 18? Okay, so I'm not just adding a 9. Yes, I'm adding a 9. But the problem is, what's the value of what I just put in? It's actually 18 because this entire side, if I distributed the 2, is 2x squared plus 12x plus 18. So even though I added 9, I have to add 18 over here. And that will look like this. Once I have this, I can just write out the 2. And I can rewrite this as my binomial squared. What is the binomial? And then what would the last thing be to get that by itself? Or to get it in vertex form? Yeah, I can subtract the 22. So y equals 2 parentheses x.
Wait, is it only your class?
So what is the vertex of that equation? Negative 3, negative 22. So the difference is factoring out. And the hardest part there is seeing that even though you're adding a 9 here, you're adding an 18 to the other side because it's not about the number that you're putting in. It's about the value that you're adding. And if you had 2 of them, technically you have 2 9s, which would be 18, not just 9. That's like the tricky part. So we're gonna practice both. It's 1 o'clock, so you have about 25 minutes, which is great. You have options here, okay? And I'm gonna explain your options before I pause. So up here are 6 problems for completing the square. Now only one of them is going to end up giving you any type of fraction or decimal. As you can see in the numbers, most are divisible by the number you would divide out. Okay, so you don't need a calculator for those. Even though we had some really challenging ones in our example, these are divisible. So this would get you pretty close and really not needing a calculator. That would be solving by completing the square. You have coefficients greater than 1. Around the room, you have some task cards up, and that would be going from standard form to vertex form. Some of those coefficients are not 1. Some are negative 1, which would be the same thing we just did. Some are larger than 1, like negative, there's a 4, and there's like a negative 2. You could try all of them. The way those task cards work, it's like a scavenger hunt. There is an order. You go to any one to start. You go to the bottom equation, which is in standard form, and you rewrite it in vertex form by completing the square. Once you know what the vertex form looks like, you find that vertex form equation on another card. When you find it, you go down to the standard form equation and you do that one. You'll end up going in an order, no matter where you begin, if you choose to do that. If you want to do a couple from up on the smartboard and then a couple from the chalkboard to do both, you can. I'll probably post some practice problems online today after school, just completing the square with a coefficient greater than 1. Tomorrow we'll spend some time working with vertex form, standard form, and solutions of quadratics all together. We're going to do like a task card activity tomorrow. Okay? So you choose. Keep in mind, you'll have a little quiz on completing the square by midweek, just because I do want to give you another little quiz before our unit ends, because we're going to take our unit exam in the 4th marking period, but you still are gonna have a little quiz on completing the square. So between today and tomorrow, you'll get a lot of practice, probably beginning of class Wednesday. Okay, I am not here Thursday, I'll be leaving. I'm probably gonna leave you a park packet, which we won't have time to get to before the park, similar to the warm-ups, but its own, for you to do during class, so that you have those 12 questions in your repertoire for the exam. It's a project on Sherweaver Trail. You guys can do it on the bus. Okay, so at this point, you choose what you would like to do. I'm going to pause the video.